Hey there, cats and kittens or something. I don't know. I'm tired. It's the end of the semester. Spring is fun. We're going to talk about inscribed angles today. Going to learn some theorems, do some practice problems. It's going to be great. So, what is an inscribed angle? Well, these are inscribed angles. So, an inscribed angle kind of has two parts. It has the inscribed angle, which is the vertex of the angle, and it is, you can see that the vertex in all three of these different types of inscribed angles, the vertex is sitting on the circle, and also it has endpoints in the circle as well, right? And so this is what inscribed angles look like. They've got endpoints. The endpoints and the vertex are all touching the angle. So let's learn our first theorem with inscribed angles. Inscribed angle theorem says that basically, written both ways, right? I've got it labeled here with colors, right? Inscribed angle, intercepted arc is what the arc that is formed with the inscribed angle is called, right? And the inscribed angle is half the measure of the arc, or the measure of the arc is twice as big as the inscribed angle, right? Easy peasy. That's not even a very hard theorem to rememberize. It's not that big a deal at all. Let's do an example or two with that theorem. So we're going to find each angle measure. So the measure of angle P and the measure of arc PO. Now, I think we talked about this in the last lesson, and I will remind you again that the order matters, right? Because PO would be this arc right here, right? I know that this would also be PO, but if we were describing one of these, we would do like PMO or PNO, right? Either one of those would be this bigger arc over here. So this one here, right? So let's start with the measure of angle P. So where is the measure of angle P? It's right here, right? So this inscribed angle right here, this one here. So what do we know with this one? Well, we know that the arc is 70. So the measure of angle P is 1/2 of 70 degrees. What is 1/2 of 70 degrees? It is 35 degrees. So the measure of angle P is 35 degrees. That's not that big a deal, right? What about PO? So PO is this arc right here. Arc PO is this one right here. So that one goes with this angle right here, right? That guy. So it is double this one. So the measure of arc PO is twice as big as 56. So 2 times 56 degrees is 112. So the measure of arc PO is 112 degrees. No big deal. Easy peasy. Let's do the next one. All right. So this theorem says, so if two inscribed angles of a circle intercept the same arc or congruent arc, so we've got these measured here. So this is in this case, it's the same arc, right? Angle C intercepts arc DA, and angle B also intercepts DA. It could be the exact same arc, which is pretty common problem type, or it could just be congruent arcs, and they could be labeled like this one congruent to some other random one over there or whatever else. But so if they're the same arc or congruent arcs, then the angles are congruent. So because it's the same arc, angle C is congruent to angle B. I know it's all labeled on there too, but just because it's all they intercept the same arc, we know that they're congruent. Let's show that with an example with less labeled on here. So what do we got here? We're going to find the measure of angle T. So we got a couple of random angles, but luckily for us, they both intercept SV, arc SV. So since this angle intercepts it, this guy right here, right? So this one right here, and this one right here, they both intercept this exact same arc, this SV arc, right? So since they both intercept the same arc, that means that angle T is congruent to angle U. So let's write that. All the measure of angle T equals the measure of angle U because of that the theorem we just learned, right? And so let's set these two expressions equal to each other. So 3x minus 5 equals 2x plus 15. All right, let's solve this for x. So let's subtract 2x from both sides. Because we're not in algebra 1 anymore, let's also add 5 to both sides. So right here, see these two cancel, and right here those two cancel. So on the left side, 3x minus 2x is just x. 15 plus 5 is 20. Now we got to stop before we just circle it and move on. We got to stop, pause. Did we answer the question yet? Measure of angle t. We did not, in fact, find the measure of angle t. So we've got to substitute this back in for t. We could actually put it in either one because they're congruent, but we'll do it in the one that matches just because we will. So we've got 3 times x, which is 20, minus 5. 3 times 20 is 60, minus 5. 60 minus 5 is 55. What is this? This is an angle, so 55 degrees, because we're labeled degrees. Good to go. Let's do the next thing. Another theorem. So an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So what that tells us that this is a diameter if and only if the inscribed angle here is a right angle, which makes sense because half of a circle is 180 degrees, right? We go from one side to the other side. It's half of 360, which is 180, which means this would half of that, and half of 180 is now 90, right? And so this makes sense. This is you could probably come up with this theorem on your own if you kind of worked your way through it and you were so inclined to do so. Let's do an example using this one. So we're going to find the measure of angle F. So that's this angle right here. So let's take a look at what we got here. Well, this is labeled as the center. So this FH is a diameter, which would make this angle right here, this angle G, a 90-degree angle, right? So how can we figure it out? So we know this is 90, but these are way over here. Well, so what can we do? What else do we know about triangles? Well, we know that the sum of their interior angles is 180. So angle G plus angle F plus angle H is 180 degrees. So how about we set that up? So angle F, so 4, I don't want to do that. I want to do 4x plus 2, that's all of angle F, plus angle G, which is 90, plus angle H, which is 9x minus 3. All that equals 180. So, oops, not 18, 180. All right, now we can solve that thing. So let's combine like terms. We've got the x terms that are alike, and then we've got the no x terms that are alike, right? So 4x plus 9x is 13x. 2 plus 90 minus 3 would be negative 1 plus 90, which would be 89. So plus 89 equals 180. Let's subtract 89 from both sides. Excuse me. Minus 89, minus 89. This would cancel, leaving us with 13x equals 180 minus 89 would be 91. So now we've got to divide that 13. I don't have my 13s memorized. Y'all have your 13s memorized? Let me know in the comments below. Let's punch that in. 91 divided by 13 equals 7. I figured it came out whole. I know some of y'all have your all the way up to your 15s memorized. I do not. I mean, 15s are not bad, but 13s and 14s, I don't have all those memorized. You may. It'd be great if you did. Be wonderful. Okay, so are we done? Can we circle and move on? Nope, we're not looking for x. We're looking for the measure of angle f. So we're going to take and substitute this guy over there. So 4 times 7 plus 2. 4 times 7 is 28. Plus 2 is 30 degrees. Degree measures right there. All right, one more theorem, one more problem, and then we're done. All right, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So in this little example, this little picture here, what that tells us is that the measure of angle K plus the measure of angle F equals 180. The measure of angle M plus the measure of angle K equals 180, because that's what supplementary means, right? It means that their measures add up to 180. And it would also tell us that L and N are supplementary, because those are opposite angles, right? So the measure of angle L, that looks stupid. Angle L plus the measure of angle N equals 180 degrees, right? So let's do an example with this theorem, and then we are going to be through. All right, find the measure of angle A and the measure of angle B. So, inscribed quadrilateral theorem says that opposite angles are supplementary. So we can take this plus this equals 180, and we can get x. Excuse me. So 2x minus 30 plus x equals 180. Right? So we got to combine like terms here. Let's do that. So there's a 2x and an x. Well, we also add 30 to both sides. We're not in Algebra 1 anymore. 2x plus x is 3x. 180 plus 30 is 210. And then we're going to divide both sides by 3. X equals 70. All right, so we need to find the measure of angle A and the measure of angle B. All right, so B is easy, right? B, we're just going to take and substitute, and then we'll get B, right? No problemo. So 2 times 70 minus 30 is going to give us angle B, measure of angle B. 2 times 70 would be 140 minus 30. So the measure of angle B equals what am I doing? 110. I don't know. It's tired. It's like almost done with April. We're going to make it. I got confused, and halfway through, you think about future and present, and it words out weird. So as it stands right now, this problem is not solvable to finish because I accidentally didn't copy down the fact that angle C in this problem is supposed to be a right angle. So now we can actually do the thing and make this happen. All right, so that one's going to be really, really simple. So for the measure of angle A, we've got the measure of angle A plus 90, right, equals 180, which would mean we would just subtract 90 from both sides, and we get the measure of angle A equals 90. clearly I didn't draw it right. You want to know how I know that I didn't? I mean, I didn't really take the time to like do this one perfect. I just copied that other picture and swiveled it around. You want to know how I know that this picture is not drawn perfectly? Well, it's because of the theorem we learned earlier. So if this was true, then this one would have to be a diameter. I know that that is pretty close to actually being the center this time. I didn't YOLO it. I kind of use some stuff, and this doesn't pass to the center, which means that this picture is drawn wrong, which is okay because the math leads us to the down the fairy garden trail to the truth of the numbers. And that's it, y'all. That's all there is to this lesson. We will see you in the next one. We'll talk about tangents, but not the trigonometry kind, the circle kind. So we shall see you there. Bye-bye.